All right, get ready, everyone, because today we're tackling the Fermi paradox. It's kind of crazy when you think about it.
Yeah.
Billions and billions of stars out there, probably with even more planets.
Hmm.
Makes you feel pretty tiny, huh?
It really does.
But here's the thing that always gets me. With all that immensity, we haven't heard a peep from anyone else. It's like, hello? Anyone out there?
Yeah, it's a real head-scratcher. It's called the paradox for a reason. And it all goes back to a pretty simple question, actually. Back in 1950, this physicist, Enrico Fermi, he was just having lunch with some other scientists, and he's like, where is everybody?
I mean, it seems like a casual question, but when you think about the odds, it's huge. Well,
Exactly. It's not just a hunch. It's about probability. And we're not talking about a few planets here. We've got the Kepler telescope showing us just how many planets are really out there.
oh man, Kepler blew the doors wide open, didn't it?
Totally. It looked at a tiny, tiny part of our own galaxy and found hundreds of planets. Just imagine hundreds.
That's wild.
So if you scale that up to the whole Milky Way, you're looking at maybe 500 million planets. 500 million. And even if just a tiny, tiny fraction of those could actually have life, the numbers just don't seem to add up.
It's true. So we've got this universe that's probably full of planets that could have life. And some of them have had billions of years longer than us to, get things going. So
Yeah.
where is everyone? I mean, it makes you wonder if there's something we're missing, something beyond. We just haven't found them yet.
Right. That's the whole point of the Fermi paradox, isn't it? It forces us to consider some pretty wild possibilities. Like, what if there are super advanced civilizations out there, but they're choosing to stay quiet? Like, they see us down here and are like, yeah, let's just watch these guys from a distance.
Ooh, that's both cool and kind of creepy, right?
Yeah.
Like they're watching us right now and judging us. Makes you think of that rule from Star Trek.
Yeah.
A prime directive, right?
Yeah.
But even bigger and more mysterious. And it makes you wonder,
Yeah.
what would a civilization that's that advanced even look like?
I know. Think about how fast our own tech has come along. I mean, we went from barely getting planes off the ground to sending stuff outside our solar system in, what, a couple hundred years? Now imagine a civilization that's millions of years ahead.
Oh, whoa.
They could be using the energy of entire stars. There's actually a way to measure that, the Kardashev scale. Like a Type 2 civilization, they'd be able to harness all the energy from their sun. Imagine that in charge of a whole solar system.
That is mind-blowing.
Yeah.
But then, knowing how powerful tech can get, it also makes you wonder if maybe some civilizations don't even last long enough to get that far.
You mean like they destroy themselves before they get there?
Yeah, exactly. Like, what if becoming that advanced,
Right.
what if it comes with risks? What if it's happened before and they couldn't handle it?
No, that's a chilling thought. It's a scary thought, for sure. It makes you wonder, what if that's the answer? What if no one makes it past a certain point?
It's definitely something to think about. But, what if it's not about them? What if it's about us? Like, what if we're looking for the wrong things entirely?
You mean like our whole approach to finding ET is off?
Yeah. The sources we read, they mention that a few times, right? Like, maybe we're so focused on finding something familiar, we miss the signs that are right in front of us.
That's a good point. Like with SETI, right? We're basically searching for radio waves, for signals like the ones we use.
Makes sense, right? That's how we communicate.
Right, but what if they've moved on? Like, imagine trying to pick up a conversation from 100 years ago, but they're using tech that's like 1,000 years in the future.
Whoa. Yeah, we'd be totally clueless.
Exactly, and that's just the tech. What about the whole idea of life as we don't know it? I mean, we keep looking for carbon-based life, something that needs water, like us, but who says that's the only way it can work? What if there's life out there that's, like, silicon-based? Or beings made of pure energy, things we can't even imagine.
Okay, you lost me at beings of pure energy, but I see what you're saying. It's like we're trying to put together a puzzle, but looking at, like, one tiny corner of the box.
That's a great way to put it. And that's what's so exciting about, like, the next 15 years or so. There's some really cool stuff happening in astronomy, new ways of looking for life.
Oh, yeah. Like what?
Well, we've got these new telescopes, right? Like the James Webb. It's going to be able to look at the atmospheres of planets that are, like, ridiculously far away. We're talking about seeing the air on a planet in another solar system.
Seriously?
Yeah. And by looking at the air, we can maybe find what they call biosignatures, basically, the chemical traces of life itself.
So even if we don't see aliens waving at us, we could see if something's breathing on those planets. Wow.
Exactly. So it's not just about finding signals anymore. It's about searching for the ingredients of life itself, even if it's just microbes or something.
That's wild. It
Wow.
really changes things, doesn't it?
It really does. I mean, even if we never find another civilization like ours, just knowing if life is common in the universe or if you're really truly alone, that's huge.
I was thinking about that earlier. Even if we never hear from ET, the fact that we're even looking, it's already doing something to us, isn't it?
Yeah.
Pushing science further, building better tech, even just changing the way we see ourselves and our place in everything.
Absolutely. It makes us ask the big questions, and when you start questioning things, that's when you really start to learn. Maybe that's part of the answer to Fermi's paradox.
It's weird. We started off talking about this paradox, this big mystery, and I gotta admit, thinking about all the possibilities, all the what ifs,
Hmm.
it kind of makes you see things differently.
Yeah, it really puts things in perspective, doesn't it?
It does. Like the universe is huge, GE, and we're down here on this one little planet, and it feels both precious and kind of fragile at the same time.
Mm.
Makes you think about why we're even here, what it all
I
means.
know what you mean.
And after going through all these explanations, like maybe advanced civilizations stay quiet on purpose, or maybe they don't even make it that far. I keep coming back to the search itself. What if the silence isn't empty? What if it's like an invitation?
An invitation. I like that.
Yeah, like an invitation to become something more, to push ourselves further, learn more, be better than we are now. Maybe that's part of why we're here, to explore, to discover, to try and reach something bigger than ourselves.
I love that. And maybe, just maybe, if we do that, if we rise to the occasion, maybe we'll be the ones to break the silence. Maybe we'll be the ones to reach out across the stars and make that connection.
Wouldn't that be something?
Yeah.
To actually find the answer to Fermi's question, not just for ourselves, but for everyone.
It would change everything.
It really would. Well, folks, looks like our deep dive into the Fermi paradox has left us with more questions than answers. But hey, maybe that's the whole point. Maybe those questions are what keep us looking up at the stars, keep us wondering, keep us searching. Because in the end, that search might be how we find our place in the universe, and maybe even create our own destiny out there. And hey, if you're as hooked on this stuff as we are, don't forget to check out that link to SETI at Home we've got in the show notes. You can actually help search for alien signals right from your computer. Who knows? Maybe you'll be the one to prove we're not alone after all.